right, let's do some practice problems from 5.7. So we want to find the arc sine of square root 3 over 2. Because this is arc sine, we are looking at a range of negative pi over 2 to positive pi over 2. So we can think about that being the first and fourth quadrants. And we want the angle that's got a corresponding point on the unit circle of square root 3 over 2. As well, that is going to be the angle with measure pi over 3, because that corresponds to a point of 1/2 square root 3 over 2. The y value of that corresponding point is the sine. So our answer here is pi over 3, and that is because the sine of pi over 3 is equal to square root 3 over 2. Okay, let's look at number 2. We want arc cotangent of 0. Cotangent has the range of 0 to pi, so it's going to be the first and second quadrants. And we want cotangent of 0. So in terms of angles on the unit circle, cotangent of theta is going to be x-coordinate over the y-coordinate of the corresponding angle. We want to find theta such that x over y is equal to 0. Right, well, that's going to be this angle pi over 2 that corresponds to the point 0, 1. Got 0 is x, 1 is y, so we get 0 over 1, which is 0. So arc cotangent of 0 is equal to the angle pi over 2, and that is because cotangent of that angle pi over 2 is equal to 0. Let's look at number 3. We want arc cosecant of 2. Cosecant has range of negative pi over 2 to positive pi over 2, so we're looking at this half of the unit circle. And let's remind ourselves that cosecant is the reciprocal function of sine. So from a unit circle, to find that function value, we would go 1 over the y-coordinate. We want a 1 over the y-coordinate to be a 2 to get the angle measure that has arc cosecant of 2, or that has cosecant of 2. Positive, so we know that it's going to be in that first quadrant. Well, if we look at the angle measure of pi over 6, that has coordinates of square root 3 over 2, 1/2. If we look at cosecant of pi over 6, that's going to be 1 over the y-coordinate of 1/2, which is 2. Arc cosecant of 2 is equal to the angle measure pi over 6, and that is because cosecant of pi over 6 is equal to, like I said, 1 over 1/2, which is 2. All right, let's look at number 4. We want arc secant of 2. For secant, we are looking at a range of 0 to pi. And remember that secant of theta is on the unit circle 1 over the x value. So we want a point that has a corresponding x value of 1/2. That's going to be pi over 3. All right, that has the point 1/2 square root 3 over 2 on the unit circle. Secant is going to be 1 over 1/2. So our arc secant of 2 is equal to pi over 3 because secant of pi over 3 is equal to 1 over that x-coordinate of 1/2, which is 2. We want arc cosine of 1 over square root 2. Because it is arc cosine, we've got range of 0 to pi. And 1 over square root 2 is the same as the square root 2 over 2. Square root 2 over 2 is just the rationalized version of 1 over square root 2. Okay, we want the angle that's got a x value of 1 over square root 2 or square root 2 over 2. Well, that is pi over 4. And so our answer here is pi over 4 because cosine of pi over 4 is equal to 1 over square root 2. Number 6, arctangent of square root 3. Because it's tangent, the range is negative pi over 2 to positive pi over 2. Tangent is going to be y over x, the corresponding point with y over x. Right, since we have that square root of 3, we're looking for a point that has in y the square root of 3. Well, that is going to be this angle pi over 3 that has the corresponding point on the unit circle of 1/2 square root 3 over 2. So we evaluated y over x to get tangent, then we would have square root 3 over 2 over 1/2. 2's cancel each other out, and that results in just a square root 3. Arctan of square root 3 is the angle pi over 3, and that is because tangent of pi over 3 is equal to the square root of 3.